wanted to discuss a recent trial that looked at really advanced technologies in type 1 diabetes, but also has important implications for how we can improve upon these technologies. This was looking at 102 children between the ages of 2 and 6 years of age. They wanted to compare Tandem's Control IQ technology, which is a closed loop, to standard of care. What they found is that children with Tandem's Control IQ closed loop technology improved their time in range to 69%. They improved their mean glucose values, and they also improved their HbA1c from 7.5% to 7.0%. They didn't have any differences in the time spent in hypoglycemia, and they reduced the amount of time above 250 milligrams per deciliter. But when we talk about time in range, we're talking about type 1 diabetes values between 70 and 180 milligrams per deciliter. Now, that isn't normal glycemia. Normal glycemia is defined as 70 to 140, or more recently termed time in tight range. Now, this value has been used outside of type 1 diabetes for quite a long time because it was a better representation of what normal glycemic values are. Children using closed loop technology were able to spend 48% of their day in this 70 to 140 milligrams per deciliter normal glycemic range. However, those in the standard of care group without closed loop technology were only able to spend 35% of their day in normal glycemia. Now, that still means that children using closed loop technology were spending 52% of their day out of normal glycemia. How does this trial compare to other closed loop trials in patients with type 1 diabetes? Well, it's very, very similar. Closed loop technologies reliably improve mean glucose, HbA1c, and time in range across various rigorously conducted long-term clinical trials in patients with type 1 diabetes. But we must caveat that statement by illustrating that mean glucose, time in range, and HbA1c are not achieving normal glycemia. They're helping patients get better glycemic control, but they're not achieving normal glycemic control, that of someone without type 1 diabetes. In fact, no technology reliably does that in type 1 diabetes, but closed loop still does improve outcomes from where patients start before they use these technologies. In order to understand how we can improve upon these technologies to get patients with type 1 diabetes closer and closer to normal glycemia, we can look at these circadian rhythm plots. These plots looking at 24-hour glucose control in patients with type 1 diabetes using closed loop technology. And what we see is that when patients are awake and eating food between, let's say, 8 a.m. and 9 a.m. all the way to midnight, closed loop technologies do not do that good of a job at improving glycemic control. They help a little bit, somewhere between 5 and 10%, but nowhere near as much during the fasted windows when patients go to sleep and wake up around 8 to 9 a.m. And this is very consistent across trials. And what this shows is that nutrition is a key factor in how much closed loop technologies are able to improve glycemic control. We know that food during the day often leads to a mismatch between the kinetics of foods like carbohydrates and rapid-acting insulins. And what we see at night when patients aren't eating these carbohydrates, and brings a highlight on how we may be able to further augment closed loop technologies to get patients closer and closer to the target, which is normal glycemic control.